So in this video, we will learn how to do all these manufacturer files, which needed to send it to the manufacturer factory and get your PCB printed. So first I have to do job files. So right click, add a new output job file. So here it show no variance, and we will add one. And I already added one, and for some reason I cannot delete it actually. But to add one, simply you go to project and variants and then add and then name it. So I name it here a prototype, so I will use that. And then OK. So after this showing up, then you go here and then you double click on the prototype. Be sure it's selected. So as we know, we have so this variant help us the component we don't need to not be in the bill of material files, basically. So we have this R7. I wrote an F, not fit, because I don't want to place it. Then I do here and then I click it, part. So now it has a cross here. Then right click. So that's mean when I generate the bill of material file, this will be not there. Of course, some design they have much more, so it's really useful. Maybe for a small design like this, it's not really necessary. You can just delete it from the file. But if you have a lot of do not place or not fit components, it's a good idea to learn about this variant. So after we did this variants file, let's check it again. So project variants, and then you can see here all our components in the schematic. And then we have this R7, which is not fitted as we did it right over here. Then you can modify the drawing. You can change this cross, like you can make it gray or cross or change the color. You can play with it. And when I print the PCB, for example, on PDF, I would like actually to see that component is not fit. So also in the layout, this is for the schematic, this is for the layout. Then OK, OK, and then save. So save the job file. I call it just job output. So when you save this job file, it should be in your project. So now I have my project here, lecture 10, and I have the job file here, which we will work on it on a bit. So we're done with this. The only thing I changed from the last video. So I did this, the reference. This is really important, especially when you make the assembly. So it's just simply origin and then set, and then I set the reference here. So it was somewhere weird. Then I also added a board shape. So you can see there is a layer board shape, and then I added to my default layers. So basically those all the layers the manufacturer need to make your PCB. So how to add a board shape is just simply add a mechanical layer, and then you choose here, you don't change this, you choose here board shape, so board, and then it will create this board shape for you. And after is has been created, you go to board shape layer, Shift S, then only this layer, and then you just draw a line. So I just draw a line like this for my board shape. So this helps the manufacturer to know what is your board shape. Save. So now let's go to the job file we just created. So I normally what I do, I like to have some documentation so I can print my PCB on a piece of paper, and then I can check if everything basically if everything is correct. So from here, BC document, and just to know like everything you're creating here, it will be created on the file, on your file. And then double click, refresh. So for some reason you have to do 50 scales and then do 100, then it's the right scale. So it's a bug in Altium. So color, so press page up and page down to zoom in and out. So that's how our PCB looks like. Then you go to pages. So I like to have to print top layer, and then I go here. I want to show holes, and then I want to see the layers. So top, and then the top layer here. So this is the silk screen. Let me just remove all layers. So just active top silk screen, and the board shape, and then refresh. So that's how it looks like my top layer. Also, sometime you will discover you made some mistakes, and it will be more clear here actually. So in advance, nothing to do basically. And then I want to add a new page, so add a page. So page 2. Then I will do so I name this as a bottom, and then I select the bottom layer here. So we don't have any components on the bottom, but we have some signals, so it's good. Can I change this? Yeah, first you can change this color if you feel it's not a nice color, the green. I thought I changed it, but it was not the case. So now we have a top view, first page, second page, bottom view. So let me recheck everything again. Yeah, so here we have actually, since it's the bottom layer, we have to activate this mirror and then show holes. So in case there is holes, and let me see here, that's correct. So that's basically everything we need. So just for reference for us, so we have a PDF file and we print it. Then okay. Then I like to have this Microsoft print, and then preview. And here you can select your printer and just print those two. And you can look at it again, page up. So that's the first file. So we can just print and print it on piece of paper. And that file will be also in your document here. So here, so if you open the PDF, it will show you both PDF you just generated. And second page is the bottom layer, which is somewhere here. So if you're not sure for any component library, then this will also, like, you can just place it and see if it's fit. And you can see here the R7, we don't want it to fit the NF1, so it's showing as a drawing here as well in the layout. So that's all about the first file. So I'm not gonna print now. So now let's create the Gerber file. So it's all the files, basically all the layout you're seeing here. That's the Gerber file. So to do that, right click here, Gerber file, and then double click, check what is it. So our board is in millimeter, we keep it millimeter. So that's the layers Altium will generate. So if some layers we don't have, then we can just remove. So top overlay, we don't have anything on the bottom overlay, for example. And we don't have anything in as a solder mask in the bottom. And we don't have any paste on the bottom, so we can just remove them. Maybe we can active this board shape, but yeah, so it's already here. There's a board shape, but let me just add it, and then apply, and then we need the drills. So with this file, the manufacturer will know all your holes, vias, holes, diameter. So all this parameter of holes and vias, it will be here as well. So basically, yeah, you just keep it default and okay. Then folder here, so we want to generate both. Generate. Then we close this. We close this. And we can see it in our file. So project output. So if you generate this for the first time, it will be project output for lecture 10 MCU, and then they will write free. So that's a bug in Altium. So if you, after you generate this file, you check the document, if it's showing free, you delete it, and then you generate again. So after you generating the file, we can check some stuff here. So let me open the Gerber again. And let me minimize this. So I open this view mate. So this actually will show me all the layers I just generate. So it's just to double check if everything is correct. So you select everything, start with J, and then you take it there. So here all the layers, and if you get confused with GTB, GTO, GTL, You can see it actually here. So GTL is layer 1, and let's deactivate all layers. So you can see it one by one. So if you go to GTL, so this is your top layer. You can color it with different color. And so on. You can check all those layers. So you can check the layer 4, how it looks, because here we have some routing. So this is the board shape. So it gives you a nice overview if you have any problem in traces or you need to fix any trace. So just spend some time before you sending the board. So this is the bottom layer. So you can also remove other layers and just check this layer. You can check the top solder and top paste if everything is correct. Of course, you can save this for yourself for your reference. So now we're done with this Gerber files. So let's do the rest of the files. And before I do the rest, like this connector, they don't have a JLCPCB for sure. And normally I don't make them place the headers, so I will remove also those from my pickup and place and from my BOM file. So save. Then we back to job file. Be sure you select the prototype here. And first I want to do the pick and place. So this is only if you want to do assembly files. And let's see what's in it. So metric, then Excel file, that's what they require, JLCPCB. Then we can see our component, commands, where they place top layer, the footprint, and the X and Y, where they are exactly in the board, and then the rotation. So, okay. Then I do generate. And it will be in the output files. So now we have the pick at the place. So you can just open it and see the file, how it looks as well. So we're done with this. Then the bill of material, which is the last file. Configure. So here we just need to add the LSC part number. So this one, the one we were placing in the schematic, if you remember, we were selecting parts here, and then we select this number. So we want to add this number as well. Then I click here to the folder, generate. And that's how it looks basically. So you have your component, the values, description, designator, and the schematic, footprint, lift library. That's you don't really care a lot, but just keep it. And then the LCSC part number, which we have just for those. We don't have for our passive components. But I want to show you, like, even if you don't have it, you can get it from JLCPCB because you specify cap 0603, and you specify the value as well. But we will see how it goes anyway. So we close this file. So now I want to open two folders here. So this is inside my project. I just make a folder called send to JLCPCB. I have my Gerber file with ENC. I can show you how it looks. So all the Gerber files start with J as we talk about them. So all those is the Gerber file, and then this drill file, you just take those and put it in the Gerber file as well. So they need both in one file. Then we have the BOM. So I copy it, put it here, and we have the pick and place. I copy it and put it here. So I will rename this BOM, and then I rename this pick place. So we don't really need Altium anymore. So we have to go to JLCPCB. Let me try to. Yeah. So first the Gerber file, grab it and put it here. Let me zoom in a bit so you can see better. So waiting for uploading. So here is our board. You can press this Gerber view. Then you can see what they're gonna do. So here you can see the top and bottom. I don't think they provide 3D. So 3D, they just show you the holes. You can check the layers. So what layers you send, you can, of course, this is just for the view of, so if you do anything, it's fine. So you can, same way what we did in the view mate, you can do also here. So we don't need this. So they already detect this 4 layers. They detect the dimension, number of how many, let's say just 5. And here, nothing really. So the standard FR4. So here you can choose lead or lead free. So if I press lead free, the price has got to $6. I will just, of course, you can choose gold also for your service finish. So those will be gold, or they will be lead or lead free. So gold $17, and the shipping is $28. So let's stay here for now. We'll not send it. I was just want to show you how it's done. So this is really important because we have this impedance profile. So you choose your stack up. So I have this stack up. So confirm. Be sure it's the right one. Then order number, normally I just remove it. Like I don't want them to write anything on my PCB. Electric test, so they will check if there is any shortcut or connectivity on your PCB. So basically that's all the basic option. You can just go around and see what each one and discover more. Then I want assembly. So you can do top, bottom, and both. So this is a new both actually. I didn't have it before. And then they have standard and economy. They just activated the standard for us. Confirm. Part placement, yes. So I need them to check if the orientation also is correct. Part selection, actually they can select the parts for you, but this is now, they are busy, but normally I just choose this one. Here all fine, then next. So this is our top, this is our bottom. Always recheck everything. We need 5 pieces. Standard PCB, next. Then you have to add the bill of material and the pick and place. They call it CPL as well. So we go here. So BOM, we just grab it, add it, pick and place. So this is moment of truth. So sometime you get errors, just try again. Process. We lucky enough, we didn't get any error. So you can see here all these passive components, because in the bill of material, I didn't write the LCSC part. It's just because I don't want to make this also video super long. So the ones we wrote, the part number, for example the STM. So you can see there is no this mark here. So in the STM there is no mark. We have the part number here, which match exactly with our part number here. So it seems it got fixed. So I just, when I messed it up, I went to 2D and then I went to 3D. So let's see the orientation if it's correct. So we can either see it from here, like, see this is wrong. So this is pin 1 and it should be, we have the indicator for pin 1 here. So rotate, and that's correct now. So unfortunately, it's always like that. You have to check your main components. For the passive, it doesn't matter. So even, so you can see here, this indicator is for the cathode. So this is wrong as well. So we do this. And then for this ESD, they put the pin 1 here, which is here. So we correct it. And for the LDO as well, we have the indicator here for the pin 1. So this is also wrong. It's frozen. So now we have pin 1 here. That's correct. Also this LED is opposite way. And the most important thing is the microcontroller as well. The pin 1 is here. So we make this. So even you do that, or in your pickup and place file here, so you can see the rotation, which is for example here. So this is 90. So you can change whatever is wrong. You can change also the rotation from this file. So instead of 90, all right, here is 0, the rotation, then you change the value to 90, and then it will be correct. Like, I don't mess up with this file because for some reason I can make it nice. Maybe you can make it nice in the, because now we have two files, one sent to production and one the output file. So the way you can make it readable, let's say, so you go to data and then you do this and next. So this is something about Excel and EU. It doesn't accept comma, so it will just show it on one field. So next and then finish. So here you can see all the rotations clearly. But the problem, if you save it and you send this file, JLCPCB will not accept it. So I feel the way I'm doing this is the easiest way for you. And you can always also open Altium if you're not sure, and then see the rotation, because you don't want them to manufacture something which is wrong. So let's see the microcontroller, for example. So I have pin 1 here and I have it here, and here this is pin 1, which is match. And for this IMU, I have pin 1 here, which is here, and then I rotate it correctly. So pin 1 is here. For the ESD, the pin 1 is here, and then the rotation is correct now. And this pin 1 here for the LDO, and I have the pin 1 here, which is correct. And similarly for the last one, so I have the cathode here, then I rotated the cathode here. So as I told you, they will, if the orientation is wrong, they will check your file and they will send you an email. But you want to save time, if you want to get it faster, then you do it by yourself. Even you rotate it from here or from the Excel, you fix your Excel pick up and place file, and that's the way you're good to go. So everything looks good now here. Then next, then we can see the final price, how it will cost. So it will cost us $111. Of course, if you pick 100, it will not cost a lot as well. So then you have to specify your application, like prototype, for example. This is just something about rules. And we can see the fee, 25. They need stencil, which costs 7.8. And yes, so some other fee, loading fees, so you can read what they want exactly. So basically without assembly, it will just cost us $7 for 5 PCBs. You can change the quantity, and also see 400 how much it would cost you, and so on. But always when you order more, like I think if you order 10, it will be around $122. Then save to cart, and then you can send it. You're ready to go. So that's it for the MCU part. Thanks a lot.